All right, we are going to put this page into our notebook on page 23. So you're going to go to your table of contents. You're going to list page 23. You're going to write creating a sample space. So this is the title for what we're going to do. This page is going to get folded in half like this to create a little book. You're going to glue, I would suggest gluing the back of this side. Glue it in on page 23 so that it opens like this. Okay. Alright, so what we're going to do is we're going to practice creating a sample space. We're not going to use the making a list method, but that is one method, making an organized list. This chance experiment that we're going to look at has you flipping 3 different coins. Making an organized list is okay if you practice it, but here are some other methods that might be a little easier, because flipping 3 coins means you have to think about 3 different things at once, what's happening on each one of the coins as we go. So in order to do that using tables, what we need to do is we need to think about the first coin. Our options are heads and tails. The second coin, again, our options are heads and tails. So what this table allows us to do is say, on the first coin I could get heads, and on the second coin I could get heads, and then that outcome would look like this: heads, heads. On the first coin I could get heads, and on the second coin I could get tails. That would look like this: heads, tails. Or if my first coin is tails, I could get tails, heads. Or I could get tails, tails. So the table helps us organize those 4 different outcomes. When I'm flipping 2 coins, this is the sample space. But I want to flip 3 coins. So these are all the options I can get from just flipping 2 coins. In order to figure out a 3rd coin, I have to take these 4 and list them on the rows here. So I'm going to say HH, HT, TH, and TT. So if this is my first 2 rolls, heads and heads, my options for the 3rd coin are heads or tails. So I might have heads, 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 or I might have heads, heads, tails. If my first 2 flips are heads and tails, I might get heads, tails, heads, or I might get heads, tails, tails. If my first 2 flips are tails then heads, I might get tails, heads, heads, or tails, heads, tails. If I get a tails on both the first and second coin, I could have tails, tails, heads on the last coin, or tails, tails, tails. So if you're looking in your table, these cells that we just filled in tell us the sample space. So there are 1, 2, 3, 4, 5, 6, 7, 8 different outcomes when you flip 3 coins. We're going to do the same thing. We're going to look at the same sample space, but I'm going to show you how to find it using a tree diagram. So using a tree diagram, what I need to do is start off with the options for flipping my first coin. I could land on heads, or I could land on tails. After that, when I go to my second coin, if I land on heads the first time, my options are either heads or tails for the second coin. If I get tails the first time, my options are the same: heads or tails. If I was going to flip a 3rd coin, I now have to branch off again. So if I go heads and then heads on the first and second coin, from here my 2 options are heads or tails. But from this one, I also have 2 options of heads or tails. From this one, I have 2 options, heads or tails. From this one I have two options, heads or tails. So in order to get the sample space, we have to follow one of the paths. So for instance, if I follow the H, I'm going to start on the H. If I get a heads, then I go to the next one, I get heads again, then I go to the next one, I get heads again. One of my paths is heads, 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 so that is the first thing in my sample space. Now I don't have to follow that path, I could follow a different path. If I follow a different path, and I still follow, well, I'm going to follow this one to start. Heads, heads, I don't have to go to heads again, I could go this way and go to tails. So it would be heads, heads, tails. So a different outcome is heads, heads, tails. I can do the same thing by following every path. So now I've gone all the ways I can go going up here, now I'm going to go this way next. Heads, tails, heads. Heads, tails, tails. And now I've done everything that I can do on the heads tree, so now I'm going to go down and do the same on the tails tree. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Tails, tails, tails. So again, my sample space has 1, 2, 3, 4, 5, 6, 7, 8 different outcomes. How many total outcomes are in the sample space? 8. From the sample space, we can now calculate things like probabilities. So here's some probability examples that are going to fit, and we're going to be able to calculate by using our sample space. I can use the sample space right here from the table, or I can use the sample space I created right here from the tree diagram. P parentheses 2 heads means what's the probability of getting 2 heads. So if I go through the outcome and it has 2 H's, that means it had 2 heads, I'm going to count that one. So I'm going to see how many of them out of the 8 follow that criteria. This one has 2 heads, so that's 1. That one has 2 heads, so that's 2. That one has 2 heads, so that's 3. That one has 1, so I'm not going to count it. That one has 2, that's 4. 1, 1, none. So 4 of them out of the 8 have 2 heads. So the probability of 2 heads is 4 out of 8, which is 1/2, which is equal to 0.5. Now, what's the probability of only 1 tails? So let's see, no tails, 1 tail, that's 1. 1 tail, 2 tails, 1 tail, it's 3. 2 tails, 2 tails, 3 tails. So only 3 of them had 1 tail, so 3 out of 8. 3 out of 8, go to my trusty calculator, 3 divided by 8, .38. Alright, what about the probability of all heads? So out of these 8, only the first one is all heads, so 1 out of 8. One out of 8 is 0.13. What about the probability that all the flips are the same? So that's heads, 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 or tails, tails, tails. So 2 out of the 8, which is 0.25. Squeeze it in there. So we need to know the sample space in order to be able to find probabilities, because it's out of the total outcomes we have in the sample space, we're looking for which ones meet our event or our criteria. Alright, so if you haven't glued it in, go ahead and glue this in. Page 23 in your notebook. And now that we've done those examples, we can move on to some practice.